So if we think of the global scenario after the impact, there was global darkness for about 1-2 years at most, and in the past, scientists used to think that the global darkness caused the total stop of photosynthesis, and this affected the food web. Nowadays, we know this is not completely correct, because there may have been global darkness for a very short period of time, months, 1 year, 2 years, but after that, the photosynthesis recovered very quickly. And why do we know that? Because we don't see the extinction of some photosynthesizers. For example, microscopic algae. These make the photosynthesis, and they didn't go extinct across the boundary. Only some organisms, only the calcareous plankton. Calcareous plankton includes all the organisms with a calcareous shell that were floating in the water column. That's why they are plantic organisms. They form part of the plankton. That's why we think that dissolution of calcium carbonate may have been the main triggering factor of the extinction at the boundary, the extinction of calcareous plankton. So what about the other organisms, larger organisms? The extinction of calcareous plankton may have caused a decrease in productivity, in the production of organic matter in the oceans. But at the same time, there were blooms, there was the proliferation of other primary producers, which were not calcareous. Some organisms in the oceans are very fussy about food, so they like some types of food, but not other types of organic matter. So this caused instability in the food web. And this affected many other organisms. For example, the large reptiles of the end of the Cretaceous, the mosasaurs, would prefer to feed on ammonites. If the ammonites go extinct, they don't have any food. This is a successive collapse of the food web.